Good morning, assuming that you're in one of the U.S. time zones, or good afternoon in the Eastern time zone. My name is Noam Shandar. I'm the Vice President of Business Development with Zadara Storage. I very much appreciate your joining this webinar, and I hope to keep it interesting and educational for you. To help me orient a little bit and understand who I'm speaking with, I have a single question that I'd like to pose. And I'm going to put up this vote now. And it is a straightforward question. Are you planning on moving any applications to the cloud, any existing applications, as opposed to creating new ones in the cloud? And the choices are no, I'm not planning on doing that. Yes, and I'd like to do it soon. Yes, but I will do it later on, or I haven't decided. So the vote is now open, and I appreciate your voting on this question. I will leave it open for about 30 seconds, and then we'll move on. A few votes have come in. Give it another 10 seconds. Okay. Let's look at the results. So we have 3/4 of the audience saying yes, and half are eventual and half are, or a quarter, as soon as possible. Good. So that helps a lot, and you'll see me refer to this in the presentation. All right. So let's get started. The title of the presentation is Why the Cloud Needs to Look More Like the Data Center. And so let me start making that argument. First, why am I posing the question? The reason that I'm posing the question is if I look at where IT dollars are spent, and I look at the cloud, and there's a lot of hype around the cloud. Despite all the hype, it's still not very large. It is growing quickly, but it's still measured in the single digits of billions of dollars per year. The largest and most famous and notorious cloud is Amazon Web Services. They're by far the largest, and they're expected to finish this year at about $4 billion, and everybody else is much smaller. In contrast, if you look at enterprise IT spending in total, it's 3 orders of magnitude larger, measured in trillions of dollars. And the question, therefore, is why aren't more of those dollars in the trillions column moving into the cloud? What's holding it back? What are the impediments to adoption of cloud? And why is it when we look at this iceberg picture, we see all of these things that are happening in the cloud, all these things that are happening on-premise in traditional data centers, whereas the use cases for cloud are more limited. And I'll argue that the answer has a lot to do with storage. And that may be a surprise, both because storage isn't discussed a lot in the context of cloud. That's usually hear about cloud computing, but also because there's not necessarily a common recognition that storage in the cloud is not what it should be. And here's the argument, and I think you will see where I'm going with this. So yes, Amazon loves to tout that they now have over 2 trillion objects in S3. That's their object storage. That's an amazing figure. It's really impressive. However, object storage is not relevant for existing applications. Microsoft enterprise packages, SQL Server, Exchange, SharePoint cannot run on top of object. Same goes for Oracle. Same goes for SAP. So if you look at the cloud in terms of the services that it provides, you can easily divide those into 3 categories: compute, networking, and storage. And if you look at compute in the cloud, it's identical to compute on-premise. A virtual machine at Amazon or Rackspace or any other cloud is the same virtual machine that you could provision for yourself on-premise. So that can't be the source of the problem. Networking, very similar. It's IPv4 networking. It has virtual LAN, sometimes called virtual private clouds. It lets you connect machines to each other. They can talk to each other just like they do on-premise, and they can even do it with reasonable performance and low latency. So that can't be the issue. And that leaves, by process of elimination, storage. But I can make a stronger argument than just the process of elimination. So let's talk about storage in the cloud. So first, what we're used to from the data center, from the on-premise environment. We're used to storage that is physical. It has very good performance. It has a very good reliability. Obviously, it works with our existing applications, or we wouldn't buy it in the first place. It supports our clustering applications. It gives us a variety of protocols like SCSI or fiber channel for the compute attach, and for block, and for file it gives us NFS and CIFS typically, and so on and so forth. So these systems work very well. They meet our needs for the on-premise applications that we run, and once they're set up, they keep running. There's some things that we don't like about them, which is why we're looking into cloud. We don't necessarily like how expensive they are. We certainly don't like how inflexible and rigid they are. We have to buy something that is the right thing for an X number of years. And also, when we have multiple applications living within our storage, it's sometimes difficult to isolate them so that they don't interfere with each other. So that's our situation on-premise, and we look to cloud to say, hey, can you make me more flexible, and can you make it easier for me to grow and shrink based on my actual needs as opposed to my predicted needs? So we go to cloud, or we take a close look at cloud, and we do find the flexibility that we're looking for, but we find that we make compromises in pretty much every other field. The performance in today's cloud storage is insufficient. Again, if I go to the leader, the market leader, Amazon Web Services, they have by far the best block storage solution out there, and it's called Elastic Block Store, EBS, and it has an enhancement called Provision IOPS EBS. It's very nice, and it'll top out, however, at 4,000 IOPS, which is I/O operations per second. And most enterprise applications need somewhere upward of 10,000 IOPS, and sometimes tens of thousands or hundreds of thousands of IOPS. So to have the best product out there deliver only 4,000 IOPS, and again, it's a well-engineered product, and it is well ahead of its competition. So not trying to knock it in any way, just showing that there's a gap, a wide one at that, between the expectations for existing applications and what cloud storage delivers. There are other limitations as far as how reliable or available it is. There have been some notorious outages, and also maybe even larger problem than any of those is the lack of consistency. Really what one wants is what I described earlier with the on-premise storage, which is that once I set it, it works. It's a sort of Ron Popeil set it and forget it machine. And with cloud storage, often the story is not like that. It is the story of inconsistency, where today's performance is one thing, tomorrow's performance is another, and I have no control over it. So it is what it is, and I can't determine what it is, and I can't affect whether it is worse or better. So those limitations are significant because they mean that if I try to move, let's say, my Exchange server to a cloud environment, there may be days where it won't work quickly enough to handle all the email that goes through it, and that's, of course, unacceptable. The end result is that those who have tried to move these sorts of demanding applications into cloud environments are unhappy, and they're probably telling their friends that they're unhappy, and that in turn causes the vast majority of enterprises to stay away, at least when it comes to these existing applications. And now I hope you're starting to see where that where the reluctance is, and why a lot of dollars, many dollars, are staying out of cloud, even though they potentially, as we saw in the survey here, there is interest in moving applications into cloud environments. So that is the kind of the preamble, And by the way, let me pause here both to let it sink in, but also to mention that you have the ability to ask questions. There's a questions button on your screen. So if at any point you want to ask a question, type it in. I will catch it no later than the end of the presentation, but once in a while I take a peek at the question to see if there's something that I can answer in real time. So with the thesis that I just laid in front of you, that cloud storage, that the main reason why a lot of applications are staying out of the cloud, where perhaps financially it would make sense to move them into the cloud, and where there's interest and will to move to the cloud, and that is probably a storage-related thing. Let me back up a little bit and talk about storage types. And that's both to bolster the point and to provide some foundation for some other points that I plan to make. So you can divide the world of storage today into three major groups. They are, from top to bottom on the slide, object, file, and block. And I made this point earlier on about object not being fit for enterprise applications. So this is the time where I put a little more meat behind that. So I'll actually start at the bottom of this slide and work my way up. So block storage is the most basic type of storage because it most resembles the way that data is actually stored on the storage devices, like the hard drive or the solid-state drive. And because this is a very basic type of storage, it is very, very efficient because the data moves in virtually the same format that it gets stored on the drive, which means no translations are needed, and which means that retrieving it is also very efficient. As a result, when one looks for very low latency storage that reacts very quickly, it tends to be block. And where you want low latency is where you have a lot of transactions. Because if you imagine if I have 1 million transactions in a given period of time, then every additional millisecond per transaction across those million transactions will add up to 1,000 seconds, which is a significant amount of time. So therefore, every millisecond, in fact, every microsecond counts, and that's where block comes in. It's very low latency. It's very good for databases where one does a lot of small reads and writes, and you can therefore see it running underneath pretty much any major database out there. In fact, you look at the little quote that I put above between the block and the file systems, you can see that, it's just an example where this is from the knowledge base for Microsoft SQL Server. They recommend running Microsoft SQL Server database on block storage, either a local block device, in other words, a local disk, or on a storage area network, SAN, which is a shared block device. Next up is file. Now, I've mentioned the good things about block. Block storage, its low latency is very simple, but also it's complex because the protocol is quite low level. It's very hardware centric. So it's not easy to manage files at the block level because really the block device doesn't know what a file is. All it knows is I have pigeonholes, which are the blocks, and they're addresses, and I either put something into the pigeonhole or retrieve it from the pigeonhole based on the address. But I really don't know what a file is. So therefore it's hard for me to manage them, do very simple things like copy files, etc. And that's where file storage comes in. It adds a protocol above block, so now it's less efficient because now there's a translation that needs to happen between the block layer and the file layer. But the upside is it's really straightforward. Files is what we're used to doing. We open files, we close files, we save files, we copy them, we back them up, etc., etc. So file is actually by far the most common type of storage in the enterprise for that reason. And when you look at document management, file servers, web servers, all of those are file-based, and they use protocols like NFS and CIFS. Block, by the way, uses protocols with names like iSCSI, InfiniBand, Fiber Channel, SCSI, and so forth. So those two are the most common in the enterprise, and almost every enterprise application, to almost no exception, use one or both of these types of storage. And then comes an object. An object is a type of file storage, but with very significant limitations by design in order to make it very simple. In fact, Amazon's S3 object store is called S3 because the acronym is triple S, Simple Storage Service. And it is really simple. It uses HTTP as the protocol, the same protocol that our browsers use, our internet browser or World Wide Web browsers. And those who are using Object can essentially do two things with their files. They can either upload them into the Object Store or download them out. So you can put a file in or you can get the file out. And that's it. You can't change it. You can't copy it. You really are only dealing with static content. And that's, there are many, many uses for static content. Most content on a website is static. If you look at, take Facebook as an example, your profile picture is static, right? It's the same picture and it just gets downloaded every time somebody looks at some post that you made, and that picture doesn't change. And then the few times when you update your profile picture, all that needs to happen is you delete the old one and you upload a new one. So classic example. Another classic example is Netflix. Netflix movies, they don't change in place. The movies get uploaded into Netflix and then they get downloaded when customers watch them, but they never have to change. So again, object storage is just perfect for that. But by the same token, because the files have to be static and cannot be changed, that means you can't use them for databases because databases write values all the time. You can't use them for file sharing because part of file sharing is collaboration and making changes, right? When I edit a Word document and then you want to add a sentence, that's a change to the file, and that's impossible in Object. The only thing you could do is delete the file and upload the new version, which is extremely inefficient. Think if you have a 10 megabyte PowerPoint and you want to change one word on one slide, you have to upload the entire 10 megabytes again. So to summarize, three major types of storage out there: block, file, and object. First two are the ones that are used by enterprises and where virtually all enterprise applications reside, whereas object is very common in cloud and not appropriate for enterprise applications. And that's a gap. That's a mismatch because in order to support existing applications, the cloud would need to offer block and file services as well. Most clouds offer only object. As I mentioned, Amazon very wisely added block, and then there are some other gaps that exist in that service versus what the enterprise customer expects. All right, so what should the data center offer? Sorry, what should the cloud offer? Why should it be more like the data center, or how should it be more like the data center in order to support enterprise applications? Well, if you look at this grid, it puts storage solutions along two axes. One is the performance, and then not just performance in absolute sense, but also the consistency of that performance. And the other axis is the flexibility. And today's enterprise storage on-premise lives in the top left. It's very high performance. It's very consistent. It's really, really solid, but it's really rigid too. And then today's cloud storage lives in the bottom right. It's elastic. It's flexible. It's also very affordable, by the way. And really what a enterprise cloud user wants is both. Okay, so the whole idea of the cloud is that I rid myself of a lot of headaches. I rid myself of the headache of planning. I rid myself of the headache of paying in advance for things that I may or may not use. And therefore, in order for storage to be successful in the cloud in an enterprise sense, it needs to combine the best of these two types of storage and live in the top right quadrant in this. In other words, yes, be elastic, and yes, be flexible, and yes, be affordable, but at the same time provide high performance with very high consistency. That is the quadrant that would be the successful quadrant. And I listed some things that are must-haves. Clustering. Almost all mission-critical enterprise applications are clustered. By clustered, I mean there are multiple servers running the same application so that should any one server fail, the application keeps on running. And to do that, those multiple servers need to share the same storage. And in order to share the same storage, that feature of sharing needs to be available, and it's not. So clustering is a missing piece. Privacy. I am used to having my data within my four walls. For me to move that data into a cloud, I need to feel that I'm not exposing it any more than I did before. So the storage needs to comprehend that and provide those assurances. There needs to be predictability. I don't want calls in the middle of the night that my Exchange server just slowed down and emails are barely trickling through. And then control. If something is not as I like it, I need the levers and knobs in order to fix it and make it better. Another way to segment the requirements is with a different 2x2 chart. And this one still has performance along the left or along the vertical axis, but it has availability along the right axis. So I didn't talk about availability in the previous slide, but I don't want to skip that. So today the choice is a similar compromise. Do I want more performance or do I want more availability? So I look, and this is looking at existing services in cloud environments. So they tend to be either storage that is local to my virtual machine, and if it's local to my virtual machine, it tends to be very fast because it doesn't have to traverse any long distance, and it attaches directly to my operating system, and therefore I should be getting good performance. And real-world experience confirms that. So the local storage is very good performance. But it's not highly available because it is only visible within my virtual machine, and virtual machines on occasion crash. And at the moment that the virtual machine crashes, I lose access to that bit of storage. It's also not shareable, which is another limitation. By the way, Amazon calls the storage correctly ephemeral storage, ephemeral meaning temporary, not lasting, precisely for this reason, because it's attached to the VM, it's part of the VM. If the VM goes away, so does the storage. That's one option, so I do get the performance, but I don't get the persistence. And then my other choices are persistent types of storage, like the various block stores that are out there. There is Amazon's Elastic Block Store. There is Rackspace's Cloud Block Storage, and their equivalent services elsewhere. And those tend to be of lower performance because they're shared and because there's more network distance to be traversed from wherever the storage sits within that cloud provider to the VMs and so on and so forth. So it tends to force me to pick either quick or reliable, and that's a false choice because one can give up neither one. Both are required. So in order for an enterprise application to run in a public cloud environment, it must have both the performance and the availability. It has to live in the top right quadrant, or else it will not move. No administrator who values his or her job would risk being in either of the quadrants with the dark blue circles. They would have to be in the top right quadrant. So if I were to put together a wish list on behalf of the owners of these applications, it would look something like this. This is a cloud storage wish list. I wish my cloud storage would give me all the control that I'm used to on-premise, which means I can define it my way, and I can change in a real time should my conditions change, and conditions do change. I want the performance. It needs to run my demanding applications the way that I'm used to running them at the same level of performance or better, and that performance is constant. It doesn't change on me. The performance I pay for is the performance I get, and I'm willing to pay more for more performance as long as I get it. It has to be secure, which means I need to maintain custody of my data. The fact that it lives on hardware that somebody else owns is no reason and no excuse for me to let go of the ownership of the data. So I want to be the only one who controls access to my data, and that's because I trust no one. And that's a really important mantra, the trust no one. We learned that we can't trust our own government not to look at our own data, and if we can't trust the government, why would we trust a cloud provider to not peek into our data as well? So therefore, the security model needs to be such that I'm the only one who has access to the data, and I'm the only one who decides who else has access to the data, and I don't need to trust the employees of my cloud provider, and I don't need to trust law enforcement agencies and so on and so forth, because the data is mine, and if anybody wants to see it, they need to come to me to be granted permission. Last is flexibility. Why did I move to the cloud in the first place? It's for flexibility. So it's got to be more affordable than what I'm doing now. I want to be able to pay by job or project. That's how I get funded. I get funded by project, so I want to be able to allocate that funding accordingly. I want to do it by hour or by day or by month, with the ability to expand and contract as needed. I may need to expand on a moment's notice because demand spikes. I may need to shrink on a moment's notice because the budget for my department changed and I need to find a way to save money. So the cloud storage wish list is holistic in the sense that all four of these need to exist together for the offering to be attractive, for the offering to meet my needs and actually be viable in terms of running my enterprise application. I want to spend a minute on multi-tenancy. That's a term that is used very often, but it doesn't have a common definition, and some people use it as a positive meaning, as a word with a positive, or a term with positive connotations, and some use it as a term with negative, pejorative connotations. So I'd like to put some definition around this and hopefully leave you with the impression that this multi-tenancy is a good thing, not a bad thing. So I define multi-tenancy as multiple tenants sharing an infrastructure harmoniously. So some people use it to mean the opposite. Multi-tenancy means interference, means what's called the noisy neighbor problem. I say multi-tenancy works if to use the noisy neighbor analogy, if the building is well constructed. If the building has thick walls and has insulation, sound insulation inside the walls, then the noisy neighbor problem is solved, even though we're still living in a dense enclosure, if you will, in a multi-dwelling unit. So there are a lot of people crammed in together, but they're not interfering with each other, not driving each other crazy. To me, that's multi-tenancy. So multi-tenancy means, to me, a well-crafted system that allows multiple customers to share the same physical hardware without ever interfering with each other. Not seldom, but never, ever interfering with each other. And that means a few things. It means full isolation in two senses. The access sense, that's the security sense. I can see your stuff and you cannot see mine. And performance. I can't slow you down and you can't slow me down. And this is true no matter how many tenants there are in the system, 2,000 or 2 million. And it also means that each of us has control over our own domain, so independently. So I can set my system the way I like it, and you can set your system the way you like it, and no settings of yours affect me, and no settings of mine affect you. To me, that is multi-tenancy. And I think as we move forward in cloud, that will be the predominant definition, because those who do multi-tenancy poorly will go out of business or mend their way and bring their system up to par. So with time, multi-tenancy will be a positive thing because it means better cost for the rest of us because we're sharing infrastructure. So therefore, we're each just paying for a fraction of the overall hardware cost, but yet we're getting the experience of being single tenants. So imagine being in your apartment but having the experience of a single-family home. That's the idea. So I'm getting toward the end of the presentation, so I just wanted to summarize the points. Again, feel free to ask questions via the questions tab, and I will check them after the slide. Also provide you my contact info after the slide should you have any questions that were not answered during this presentation. So in order to funnel more of those trillions of dollars of IT spend into cloud environments, the storage within clouds needs to be better. It needs to be more similar to what exists today in data centers, and it needs to combine the best of these two worlds, the IT world and the cloud world. So it has to maintain those things that are good about enterprise storage, that's the high and consistent performance, the control or configurability, the reliability or availability, and the security or privacy. Those are critical. Those are not areas where one can compromise. So those have to be retained as we make the move from on-premise to the cloud. But there needs to be new attributes that didn't exist before. The cloud economics, which is the affordability because of this well-done multi-tenancy that I described, the flexibility, the elasticity, the ability to grow and shrink on demand, and then self-service. I need to be able to control my environment myself in real time. And if we do all of that, then we accelerate the migration to the cloud because we're minimizing change. We're minimizing the differences between the existing environment and the new environment, and therefore there's less work needed in order to make the move. And by requiring less energy and time and money to make the move becomes smoother, there's less friction involved in the move, and therefore we will see more of those trillions of dollars move, migrate, and be spent on the cloud. With that, I'd like to thank you. My contact information is on the screen should you have any questions that you don't want to ask in this forum. And I have my questions tab open now, looking to see if any of you have questions. And so far, none. I will probably wait 30 to 60 seconds to see if anybody wants to type in a question. And if none appear, I will end this webcast. Okay, so we have a question that has just come in. As you have said, multi-tenancy is a positive term, but that is possible only when performance and security both are ensured by cloud providers. When multiple VMs are sharing a single disk, or for example, how can it be ensured that performance is not affected and that isolation is guaranteed? Okay, wonderful question. Not going into a product pitch, but encouraging you to contact me afterwards, I will say this very succinctly. With the product that my company offers today, the disks are never shared among tenants. That was true before. It's will continue to be true, and that is how we answer that question very directly. So spindles or SSDs, for that matter, are not shared among tenants, and therefore the data is not commingled, nor is the performance of one disk affected by more than a single tenant. By the way, you can infer, but I'll make explicit, that our choice to not share disks is a reflection of our belief that sharing disks is not tenable for exactly those two reasons, performance and privacy. Not everybody agrees with us on this, but that is our strongly held belief, and that's why we architected our product the way we did. Any additional questions? And I think it is the same person. The question is, then how is scalability achieved in that case? And again, I don't want to get into too much of a product pitch because that is not the point of this presentation. And if you provide, if the questioner can provide contact information, I will contact you directly with more details. But scalability is part of the product. So the product is completely elastic. Scalability is achieved by adding additional drives, and the software layer above the drives makes the storage volumes that are visible to the operating system grow on demand. So there's the ability to add drives, and there's the ability to non-disruptively grow volumes based on the additional drives that have been added. any additional questions? Give it another 30 seconds in respect of your time. All right, just received the follow-up from the same person, so thank you very much. I will follow up directly with you after this presentation. And with that, I would like to thank everybody for your time. I really appreciate the attention. I appreciate the interactivity. I hope you found this useful. Again, my contact information is on the screen should you have anything that I can help you with. Have a wonderful day, and goodbye.